Hey Rams! So today we're going to be going over section 10.5, which is angles related to a circle. By the end of this lesson, what you should be able to do is find the measures of angles and arcs based on their relationships to one another. In other words, we have to see where the vertex of the angles are. Are they on the circle? Are they in the center of the circle? Are they in the middle of the circle? Are they even outside of the circle? And from there, we're going to be able to figure out their measures. Check this out. So what we've already learned is there's something called a central angle, and all a central angle is when you've got an angle's vertex on the center of an angle. Now when we know it's located there, when the vertex is located there, all we do to find the angle x is we check out the intercepted arc and they equal each other. That's a no-brainer. We did that at the beginning of the chapter. Let's go on. Okay, so what could be new now is something called an inscribed angle. And what I have over here in parentheses is on, which what I'm talking about is the vertex. We're always identifying the location of the vertex of the angle. And in this case, it's on the circle. We could see where point B is. The vertex is literally on the circumference of the circle. That's called an inscribed angle. We could see over here on the right, the vertex is also on the circumference of the circle, and that's also an inscribed angle. Let's check out what it opens up to. Over here, it opens up to arc AC. And on the other side, it opens up to this arc here, arc AB. Checking out the one on the left, the first one, the way we solve this, and I'll show you on Geometer's sketchpad in the class, the way that we would solve this is we would identify the intercepted arc, in other words, the arc that's in between the legs of the angle. So we've got 100 degrees and we divide it by 2. That's how we find angle X. And again, in class, I'll show you on Geometer's sketchpad how that works. And the one on the right, it's the same thing. We've got in between the sides here, we've got an intercepted arc of 120 degrees. Now a central angle, if it intercepts this arc, the central angle will be 120 degrees. In this situation, the central angle would look like this. But we have B. And that opens up to 120 degrees also, but because it's an inscribed angle, we're going to have to use this formula, and we do 120 divided by 2, and angle B is 60 degrees. And taking a look at the circle on the left, we do 100 degrees, because that's what's been intercepted, divide it by 2, and we get angle B is 50 degrees. So central angle, just to point it out again, I would say angle AOC, it opens up to the intercepted arc of 100, and that angle would be 100. But when we pull the vertex back to this location, it's going to be half of 100. In this case, it's 50. So just as a recap, we have our central angle that we've learned. We just checked out the inscribed angle. Now we're going to check out a chord angle. And I have in parentheses here, because this angle's vertex is literally inside the circle, not the central part of the circle, but hanging out somewhere inside the circle. And they're made by 2 chords. So here I'm going to ask you, how would I find angle X? Now, some people might assume angle X is 70 degrees, but again, angle X is not a central angle. It's not at point 0. I'm sorry, point O, we could call it in this case. It's over here where E is. It's inside the angle, not in the center. So what we have to do to investigate this is check out the 2 chords that make it. And I have this segment here and this segment here. If I extend BE, I have chord BA. And if I extend DE, I have chord DC. Now let's check out what they intercept. I have CA intercepted, and I have BD intercepted. Now the way to find a chord angle, an angle whose vertex is somewhere inside of your circle, I use this formula over here. And again, I'll show you on Geometer Sketchpad in class how it works. But I take one intercepted arc, which is right here. I add it to the other intercepted arc, which is right here, and I divide by 2. So in this case, I would do 170 plus 70 divided by 2. I get 240 on top, divide that by 2, and my answer is 120 degrees. So angle X is 120 degrees, not 70 degrees. Why isn't it 70 degrees? Because it's not a central angle. It's just hanging out somewhere inside, not allowed to be a central angle though. Alrighty, Rams, another recap. Let's back it up. Central angle, we figured out. Inscribed angle, we learned today. We just take the intercepted arc, divide by 2. And then we had chord angles, which are vertexes that are hanging out somewhere inside of the circle. And we took the 2 intercepted arcs, added them, and divided by 2. Is there anywhere else we could have a vertex of an angle? So far we saw there's one inside in the center. Another one we looked at, it was actually on the circumference of the circle. The one we just looked at, it was hanging out inside of our circle. Is there any other place? I'm so glad you asked. Yes, we could have a vertex swimming somewhere around outside of our circle, but still grabbing onto the circle, so there's a relationship between them. Let's check out this over here. We've got angle B. Angle B is saying, help me figure out what I am. What's my measurement? Well, I do have 2 intercepted arcs from A and C. The first one is the large one. If you see it between A and C, it is way out over here. It's 260 degrees. The other one is inside here. It's 100 degrees. What I have to do is subtract those 2 and divide by 2 to find angle X. So the math I would do is 260 minus 100. Remember, you only add them if it's inside of your circle. Here the vertex is outside, so I subtract and then I divide by 2. So I get 160 divided by 2, and angle X has an identity. It's 80 degrees. So happy. Let's check out angle C over here. We've identified the vertex as being outside. My next step is asking myself, what are the 2 intercepted arcs? I've got this one here, AE, and I've got the other smaller one, 20. What's the math I do? I subtract the intercepted arcs. 80 minus 20 divided by 2, and I get 60 divided by 2. Angle X in this situation is 30 degrees. Alrighty, loves, another summary. Checkpoint here. When we have an angle whose vertex is on the center, all I need to do is identify the intercepted arc. Once I identify the intercepted arc, that angle equals the measurement of the intercepted arc. If I have an angle and I have identified the angle's vertex as being on the circle, in other words on the circumference, literally hanging out on the circumference, I take the intercepted arc, and there's one more step I have to do to it. I have to divide it by 2. If I spy an angle and the angle's swimming somewhere inside of that circle, then I need to identify the 2 intercepted arcs. I'm going to say intercepted arc 1, and I add it to intercepted arc 2, and I divide by 2. Last situation. If I identify the angle's vertex as being somewhere outside of that circle, I'm going to identify the intercepted arcs. I'm going to subtract them. This is intercepted arc 1 and intercepted arc 2. Always the first one, intercepted angle 1, has to be the larger measurement. Subtract it from the smaller arc, and I divide it by 2. Those are the things you're going to have to identify. Number 1, is the angle's vertex on the center? Or is the angle's vertex on the circle? Or is the angle's vertex somewhere inside the circle, but not a central angle? or is the angle's vertex outside of that circle? Once you've identified those, we can figure out which one of these handy dandy, nifty, awesome, cool, killer formulas to use, and we could solve. Good stuff, people, good stuff. Alrighty, Rams, here we go. Example 1, woohoo! Example 1 is not asking me for angle C. Tricky, tricky. It's asking me for the measurement of arc BE. Uh-oh. It is not time to freak out, though. I've got a formula. I recognize that angle C is outside of my circle. So I'm just going to say the measurement of my outside angle is equal to the outside intercepted arc, which is 125 in this situation, minus the inside intercepted arc. I don't know what it is. It's Z, and I divide it by 2. My job at this point is to solve for angle Z, right over here. How do I do that? Let's multiply both sides by 2, and I get 64 equals 125 minus Z. Do a little bit of algebra, subtract 125 from both sides, and I get negative 61 equals negative Z. Divide by negative 1, and I have Z equals 61 degrees. Please recognize in this example, they are not looking for this angle that's given to us. We are looking for the arc, and we did not freak out because all we did was stick it into this formula. Good job, Rams. Good job. Next one. Example 2. I've got an inside angle. It's given to me, though, it's 54 degrees. It looks like they're asking me for arc AB. So, back up to the formula. I know the inside angle is equal to the sum of the intercepted arcs, x plus 65, divided by 2. Multiply both sides by 2, and I get 108 equals x plus 65. Subtract x from both sides, and I get x equals, beautiful, 43. And what is 43 degrees? Arc AB is 43 degrees. Nice job, Rams. Number 3 coming up. Here we go. This one is saying, find the measure of angle 1. All right. Okay, what's given to us, Rams? What's given to us? We know arc AB is 120 degrees given to us. Arc BC, we don't know. Do we know the measurement of arc AC? Well, I know angle B is 40. Arc AC must be 80 degrees. So I have 80, I have 120, and if all three areas need to add up to 360 degrees, that leaves me with arc BC equaling 160 degrees. Let me repeat that. If the entire circle needs to measure 360 degrees, and I've identified arc AC to be 80, arc AB to be 120, then arc BC must be 160. If arc BC is 160, to find angle 1, the measure of angle 1, I know that's equal to half of its intercepted arc. Now I've got angle 1 is 80 degrees. Example 4. So it's asking me that I've got to find the measure of angle A. And to do that, I first recognize it's an outside angle. The vertex is on the outside. So what I need to do is find arc BC, subtract it from 85 degrees, and divide it by 2. I don't know what arc BC is yet, but I could find it. Because I know that the angles around the entire circle need to add up to 360, I can say that arc BC plus 115 degrees plus 85 degrees will equal 360. Given that scenario, arc BC must be 160 degrees. Let me put that in now. Now that I have all the information I need to solve for angle A, let's do it, people. Measure of angle A will equal 160, the larger intercepted arc, minus 85, the smaller intercepted arc, and I divide it by 2. Once I solve for that equation, I get 75 divided by 2. Keep simplifying it, and that angle equals 37.5 degrees. Nice job, Rams. Listen up, family. We are in the home stretch. We could see the finish line. Check out example 5. Given measure of angle P equals 60 degrees. Okay. And the measure of arc PSR right here is 128 degrees. Find measure of angle Q, measure of angle R, and measure of angle S. Okay, let's figure this out. Now, while it looks like it hasn't given me that much information, let's go with what we have. So far, I know that PSR is 128 degrees, and I recognize angle Q is on the circle. Look at the angle that has been made right here. Do you agree with me that that opens up to arc PSR? If you do, then we know measure of angle Q will equal half of that intercepted arc, and I get 64 degrees. I'm going to write that in here. 64 degrees is angle Q. Again, because the vertex is on the circle and it opens up to arc PSR. I divided 128 by 2 and I got 64 degrees. What else do I know? I know that angle P equals 60, and what does that mean? Well, let's check it out. To me, that's saying that this angle here opens up to arc SRQ, and SRQ, let me identify it in red, is going to be 120 degrees because it's twice angle P. Okay, what else do I know? Let's check out angle R. It looks a little sad and lonely down here. Angle R opens up to arc SPQ. I don't know what SPQ is yet, but I do know the entire circle is 360 degrees and SRQ is 120. So SRQ is 120, and I have to add that to arc SPQ. That's a pretty little Q. And it has to add up to 360 degrees. Subtract 120 from both sides, and arc SPQ then equals 240. Let me write that in. Arc SPQ is 240. And ladies and gentlemen, that's what angle R opens up to. If angle R opens up to an intercepted arc of 240 degrees, angle R is half of that. And I've got 120 degrees. So the measure of angle R is 120. The last thing they're asking me for is angle S. Well, I've got a quadrilateral sitting pretty comfortable in that circle, and I know the sum of all angles of a quadrilateral must equal 360 degrees. So if I take angle S and I add it with 60 and also 64 and also 120, they have to equal 360 degrees. If I do a little bit of algebra, I will see that angle S equals 116 degrees after I solve for S. That, my friends, solves everything that they're asking for. Good job. One more to go. Alrighty, family, last one. You're doing so great. Let's check out example 6. Given arc AB is 92 degrees. Let me write that in. Also, angle AEB is 82 degrees. That's this angle in here. They're asking me to find arc AD. Okay, how am I going to do that? I haven't been given that much information, but let's see what we have. I've got an interior angle, it's 82 degrees. I've got an intercepted arc on one side, which is 92, and I have an intercepted arc over here on the other side. So I'm going to piece this information together. I know that 82 degrees is the sum of its intercepted arcs, which is 92 plus y, and I have to divide it by 2. Let's solve for y. Well, because we can. Let's see. Multiply both sides by 2, and we get rid of those. Multiply this side by 2, and I get 164 equals 92 plus y. Subtract 92 from both sides, and I figure out that y equals 72 degrees. Okay, that's great, except they're not asking me for this arc. I'm going to take out the y. I'm going to call it 72 now. So what? I still, though, need to find angle x. How did that help me? Let's see what we have here. It says here, this fun little congruent sign, I've got chord AD and chord BC equal to each other. Would you agree with me if arc AD is labeled x, arc BC also can be labeled x? They should be congruent given from what we learned at the beginning of this chapter. Okay, we've got an entire circle here. All arcs here need to add up to 360 degrees. So would you agree with me, though, that 92 plus x plus 72 plus x equals 360? All I did was add up all of the arcs. Let's keep solving for x. So I know that 2x plus 92 plus 72 equals 360. Subtract 92 and 72 from both sides, and I get 2x equals 196. Divide by 2, and I find out that x equals 98. That means this is 98 degrees, and this is 98 degrees. And now we are done. This is your homework for tonight. I know you're going to rock it. See you tomorrow.